So if you remember, before Aurudu, we spoke about log functions and exponential
Recording in
functions.
progress.
Today we are going to talk about exponential functions as mathematical models. So we learn the basic of an exponential function. So now today we are going to solve application type problems based on these exponential functions. So suppose that qt represents a quantity, right? Then the function qt is given by q naught e to the kt, where q naught and k are positive constants. And they have the following properties. That is, at t equals 0, you take the initial value to be q naught. This is the initial value. And the other thing is, qt increases rapidly as t increases without a bound. So you know that as t approaches infinity, e to the t will approach infinity. So as t approaches infinity, e to the t approaches infinity. So that's what it says here. qt increases rapidly without a bound. So this is the graph of qt, where qt is q naught e to the kt. So when t is equal to 0, the initial value is q naught. Do you all understand? Right. So qt represents the quantity at time t, and k we call it the growth constant. So example, interest earned on an FD when compounded continuously exhibits exponential growth, right? Interest earned on a fixed deposit. So it grows exponentially. I mean, there is no bound. As t goes to infinity, the money will also go to infinity. Of course, there is this time value of money. So if we know the time value of money, it just grows. And if interest is compounded continuously, it grows in an exponential manner. So exercise 1. Let's see this. The growth rate of a bacterium coli is proportional to its size. So what does it say? The growth is proportional to its size. The number of cells in a culture doubles every 20 minutes. So if you start with 10, every 20 minutes it will double 20. So in another 20 minutes it will double to 40. In another 20 minutes it will double to 80. Every 20 minutes it doubles. Right? If the initial population is 100, determine a function for qt. So qt is the exponential growth of number of cells of bacteria. So how do we write the formula? So I said the formula is qt. This is for exponential growth. Okay. qt is q naught e to the kt. This is for exponential growth. So q naught is the initial population. So they say the initial population is 100. So instead of q naught, we can write 100 e to the kt. Right? Now we have three unknowns. qt is unknown, k is unknown, t. So what else have they given? The number of cells in a culture doubles approximately every 20 minutes. So you can use this to find k. So doubles. If you say double, so for qt, what should I substitute? What should I substitute for qt? Now initially there was 100, right? So doubles 200. 400, 800. So for QT, what should I substitute? Every 20 minutes it doubles. So what should I substitute for QT? Any guesses? 200, yes. So if you substitute 200 here equals 100 e to the, instead of k, you keep k, instead of t, we plug in 20 minutes. Okay. So you plug in 20, don't need to convert it into hours. You get to save it. So I can divide 200 by 100. The zeros will cancel. So we have 2 equals e to the 20k. Now how can I solve for k? Now I have to bring this k down. K is in the exponent. Now I have to remove this exponent. Right, and bring it down. So how can I remove it? What do I do? I take ln on both sides. ln. So if I take ln, I'll have ln 2 equals 20k ln e. 20k ln e. What is the value of ln e? We learned last class. What is the value of ln e? Who can remember? Natural log of e. What is natural log of e equals to? What is natural log of e equals to? Others, what is the natural log of e equals to? That is the value of e, no? I'm asking natural log of e. ln e. ln e is, yes, 1. So then k will be equal to, right? So I can write here, k will be equal to ln 2 divided by 20. So we have k equals this amount. You can divide and get the answer. ln 2 divided by 20. Then we can write the equation for qt. So qt is equal to q naught, which is 100, the initial value, e to the power k, this value, 0.0035 kt. So this is the formula for qt. Did you all understand? Did you all understand? So this is how we write an equation for the function qt. Qt is the quantity at time t. And so what did we do here? What did we do? From all these steps, using all these steps, what did we do? We found k. Right? We do all this to find k. We do all these steps to find k. Once you have k, you can write qt. So that's what they say, find the amount of cells at time t. Now next one, what are they asking you? how long will it take for the colony of 100 to increase to 100,000? So try it on your own. So there, how long means they are asking for t. Right? When you say how long, they are asking about the time. So initially it start off with 100. Then it keeps on increasing, right? It doubles now. Every 20 minutes it doubles. So they are asking how much time it will take for it to reach 100,000. So you have to find t when the population is 100,000. So please do it. So again, what did we do here? We found K and we wrote an equation for Qt. Qt is Q naught e to the kt. Now the next question is, how long will it take for the population to reach 100,000? How can we do that? So we have Qt equals 100 e to the k is 0.0035 or something, right? T. So if the population is 100,000, 100 e to the whatever k, I can't remember the exact value, right? So we can divide by 100 and then take ln on both sides, right? ln e 0. So ln 1000 equals 0.0035t ln e. So these are using log rules, right? If it is in the exponent, you can bring it to the front. So what is the value of ln e? What's the value of ln e? Again, you should be familiar with this ln e. When I say ln e, what's the value of ln e? ln e is 1. ln e is 1. E is 2.718 E. But here I'm talking about ln e. So ln e is 1. So you can divide ln 1000 divided by k 0.0035 equals t. So here instead of 0.0035, I have substituted 1 over 20. You can do it anyway. So you get P equals 199. Now they are asking. Okay, you all can copy this down. Sorry, I think I was muted. Okay, so in the next part, they are asking you to find if the initial population is 1000, how would this alter our model? So what is the alteration? So again, if the initial population changes, you have to find K, right? So using 1000, find K. You all know every 20 minutes till that statement holds true. That is every 20 minutes, this population doubles. So initially, if it starts off with 1000, in 20 minutes, it will be 2000. In another 20 minutes, it will be 4000. In another 20 minutes, it will be 8000. It doubles. So now try to find value. Find K and let me know the value. Find K and tell me the value. Please do it. This is a good practice for you. Otherwise, because usually for exams also you get these type of problems. So please do this by yourselves. All of you take your books and please work this out. So how to obtain 199? You divide ln 1000 by k. Divide and see whether you get the answer. Ln 1000 divided by k. Forget about this. This I have taken it as 1 over 20 and has done it. Forget about this. Do this method. Part B. Did you all find k? Part C. Did you all find k? What is the answer for k? Did you all find k in part C? So you got the same k, 0.00345. So you get the same k. Right? We get the same k. Now substitute that and find how long it will take to reach 100,000. Right? So you start with the same K. So 100,000. Initial population is 1,000 e to the 0.00345 or whatever into t. ln 100 equals 0.0 0.00345 t ln e. So ln e is 1. So t equals ln 100 over. What is the value you get for t? Solve it and tell me what's the value you get. You get 132 point whatever. 88. 88 minutes. Okay, next problem. Next problem. Okay, now let's see next problem. Exponential decay. Now the earlier problem was the exponential growth, right? Where the bacteria population increased without a bound. Now we are talking about exponential decays. Decay is something decreasing. So here, look at this problem. Before that, look at this equation. So earlier we had Qt equals Q naught e to the Kp. But here, instead of e to the Kp, we have e to the minus Kt. Because it's decaying. Since it's decaying, there is a minus sign. So what does it say? Phosphorus 32 has a life of 14.2 days. If 100 grams of this substance are present initially, find the amount present after t days. What will be the amount present after 7.1 days? So can you all try this? Can you all try it? What does it say now? Earlier, we spoke about increasing functions. Here, we are talking about a decreasing function, right? Initially, they say at t equals 0, there's 100 grams. Initially, there's 100 grams. Then it decays, right? Initially, there's 100 grams. Then it decreases and decreases. What will be the amount after 7.1 days? So, just like before, write the equation. Qt equals Q naught e to the minus kt. Why we put a minus sign? Because it's a decaying function. So, it has a half-life of 14.2 days means it takes 14.2 days to become half. ඒ කියන්නේ ළමයි ඉස්සෙල්ලා 100 තිබ්බා. Initially 100 grams. Then after 14.2 days, it becomes 50. And again after another 14.2 days, it becomes 25. Likewise, it decreases. After 14.2 days, it becomes half. Again after another 14.2, it becomes half. So that's how it goes, right? It keeps on decreasing. That is what is meant by a half-life. භාගයක් වෙන්න කොච්චර කල් යනවා? half-life. Well, just like before, we have to find k. That's our goal one. You have to find k. So in order to find k, so we have to plus substitute whatever we know. So 100 grams is present initially, so that is Q naught, right? And after 14.2 days, we will have, how much will we have? We will have 50. So 50 equals initial 100 e to the minus k and t is 14.2. Okay. So we can divide it. So this will be 5 divided by 10, which is 0.5. 0.5 equals e to the power minus 14.2k. Now, how can we remove this k from here and bring it over here? In order to remove it, you have to take natural log on both sides. So, ln 0.5 equals to minus 14.2k ln e. So, ln e is 1. So, k will be equal to minus ln 0.5 divided by 14.2. Now do this and find k and tell me what the answer is. What is the answer k? So any problem, first that you have to find k. Did you all find K? What is the answer for K? 133. K is 133. K should be 0.0488. No? Zero point 0.0488. Right. Now once you find K, you can write down the equation. So Qt equals initial value is 100 e to the minus, don't forget the minus sign, 0.0488 t. So what will be the amount after 7.1 days? So they have given t. So you are asked to find Qt. So Qt 100 e to the minus 0.0488 and instead of t plug in 7.1. Now find the answer. Multiply 0.488 by 7.1 and find the answer. $70.7 grams. Okay, any questions? Any questions? Okay, let's move on to the next problem. Wood deposits recovered from an archaeological site contain 20% of the carbon-14. How long ago did the tree which the wood was obtained die? So what are they saying here? They are saying that there is this tree which has died and they have obtained carbon 14 from this tree or from wood. And they say that 20% of the carbon is contained. How long ago did the tree from which the good was obtained done. So there is some assumption. The amount of carbon-14 in tissues of a living plant or animals is constant. However, when an organism dies, the amount diminishes. So it's a decaying function because of the natural decay of the radioactive substances. So C14, carbon-14 is a radioactive substance, right? So it decreases. Because of that, the amount of carbon-14 also decreases. So we assume that the decay constant is given. The decay constant is given. So here K is given. So what do we need to find? We need to find how long ago did it die. That is, we need to find T. So now, initially, we don't know how much it contains. Let's say initial amount is Q now. Now, there is 20% of Q now. Initially, there was Q naught. Now, there is 20% of Q naught. Q naught, now it's 20% of Q. So if you substitute this equation, Qt, so for Qt, we substitute 20 over 100, 20% of Q naught. Original amount we don't know, that's why we write as Q naught. E to the minus K is given 0.000121. Okay. So we can cancel these zeros. Also we can cancel Q naught. So we have 0.2 equals e to the minus 0.000121t. Now to remove this, I can take ln, right? So 0.2 equals minus 0.000121t ln. So ln is 1. You can find t. So t will tell you how long ago it died. So do this and find t. And if you have any questions, please ask. So what's t? What is the value for t that you get? If you do this, what's the value for t that you get? Weak value, 13,301. So it has died 13,301 years ago. Okay, I hope this is clear. So here you have to remember that ln e is 1. That's the most important thing. And any problem you have to find k. Here the thing is k is given, you have to find t. And here the initial value is not given. So you take it as q now or even as x. You can take it as anything. If you take it as x, so now it will be 20 over 100 times x. Because the initial value is not given. So had it been x, the value now will be 20 over 100 into x. Okay, now let's see the next problem what we have. We have a learning curve. What do you mean by this learning curve? The graph shown below, right? Here the graph corresponds to negative values of t as well as positive values. So the negative values are drawn with a gray line. Okay? In practice, in reality, you all know that t is always positive. We talk about only positive time. So here, the positive timings, we have it in blue. Right? So we can see from this graph that QT, that is some quantity, right? This graph shows a quantity. So this quantity increases rather rapidly initially. Right? It increases rapidly, but after some time, the rate of increase slows down. And the value never exceeds y equals c. So this learning curve is given by this equation c minus a e to the power minus kt. Right? So C is the upper bound. It never reaches beyond C. C is the cap. It can't go beyond C. So QT is C minus K e to the power minus KT. So the initial value, if you plug in t equals 0, the initial value will be C minus A. So the behavior of this graph resembles a learning pattern experienced by workers engaged in a highly repetitive work. Right? So if you are engaged something in something that if your work is repetitive, you are engaged in something that repeats. So this curve then resembles that type of work. Because for example, the productivity of an assembly line worker increases very rapidly at the early stages, right? So if you work in some line, then at the beginning, initially, right, your productivity. Productivity increases very rapidly with training. Along with training, it increases rapidly. So this is because of the training and the experience that you gain. But with time, the rate of increase of productivity slows down and it approaches some maximum level or a fixed level due to the limitations of the worker, or it can be due to the machine. So because of this, it cannot go beyond C. So the productivity won't go beyond C. So that's why we call it a learning curve. So in a learning curve, initially, along with training, right, the productivity increases rapidly. ඉක්මනට වැඩි වේගෙන යනවා. හැබැයි එක කාලයකට පස්සේ, after some time t, then the rate of increase, the productivity slows down. It increases, but in a very slow manner. Right? හිමින් තමයි වැඩි වෙන්නේ. හැබැයි එක ගානකට වඩා it will not go beyond y equals c by because of the limitations of the worker and of the machine. අපි කොච්චර ඉගෙන ගත්තත් දෙයක්. අපි කොච්චර repetitively කරා. අපිට එක ගානකට වඩා වැඩියෙන් යන්න බෑනේ ළමයි නේ. I think now if I take this course, so maybe this is like the which batch y'all now? We had one in 2017, 18, 19, 20, 21, 22, 23, 24, 25. All are 25 now. So I have taught this course for about 8 or 9 years. Still, there is some cap that I can't go beyond that cap. Okay? So that is called the learning curve. Even if you do the work repetitively, still you have a maximum amount that you can do. The productivity is limited. Can't go beyond. So that's why we call it a learning curve. I hope it's clear. Right, do this problem. It's very easy problem. They have given the equation. You have to just substitute the values. The American code finds that the average student taking advanced machine shorthand is typing, an intensive 20-week course progress according to the function. So that person productivity or like progress according to this function where QT is the number of words per minute. So what is the beginning shorthand speed? So that is at t equals 0, what is the speed? Then what is the speed? Halfway through the course. So this is 20 weeks, no? So halfway through, you should know what to substitute. And after completing the course, what is the shorthand speed or how many words a student can type per minute? So just find these three and give me the answer. Initially, halfway through and at the end of the course. So you write QT equals 120. 1 minus this equation plus 60. Beginning means you plug in t equals 0. So e to the power 0, what's e to the power 0? Even if you write e to the power minus 0 or e to the power 0, it will be 1. So 1 minus 1 is, this part will be 0. So the initial speed is 60. Halfway through the course, you have to plug in 10. 121 minus e to the power minus 0.05 into 10 plus 60. Calculate it. And at the end of the completing, once the student completes the course, at the end of completion, tell me the answer. Did you all do for 20? At the end of the completion of the course, what do you get answer? What is the answer that you get? Did you all do it? So 135.85. Others? So far, we learned three models, right? Exponential growth, exponential decay, and this learning curve. And the last model is the logistic growth function. So the logistic growth, it takes an S shape or a sigmoidal curve. We call this a sigmoidal curve or SH, which is the graph of the function of, so the logistic curve is given by Qt equals A over 1 plus B e to the power minus Kt, where A, B, K are all constants, and Q is called the logistic growth function. And this is how the shape looks like. So observe that Qt increases rather rapidly for small t. So look here, in this part, it increases rapidly, right? So for small t, it looks like a normal logistic curve. However, the rate of growth decreases quite rapidly as t increases and Qt approaches A as t gets larger and larger, but Qt never exceeds A. So just like this learning curve, right? So at the beginning, it increases rather rapidly, but with time, the rate of increase slows down, right? With time, rate growth decreases. So still it increases, but at a decreasing rate, not as fast as initial. Initially, it increased very fast. So here also after some time also it increases, but not as fast that happened initially. So with time, as t increases, Qt approaches A, but it never exceeds A, right? It never goes beyond A. A is the maximum. So what is the example? If a small number of rabbits were introduced in a tiny island in the South Pacific, the rabbit population might be expected to grow very rapidly, right? So you assume in this island there are only rabbits, no other animals, only rabbits. So what will happen? Initially, the rabbit population will increase very rapidly. But with time, what will happen? Will they have enough food? No. So the population growth rate will decrease quickly because of this overcrowding, scarcity of food, and other environmental factors. Right? When the population increases unexpectedly, so there is always a competition, right? Competition for food, competition for shelter. So there's always a competition. So because of this competition, right, the growth rate will decrease. So and eventually the population will stabilize at a compatible level. So with life support capacity of the environment, it will settle at some compatible level and it cannot go beyond this level. And this level given by A, so is called the carrying capacity, Y equals A, right? That is the maximum the environment can hold. So that is called the carrying capacity. So initially you can see the rabbit population will increase rapidly, but with time rate of growth will decrease and it will come to a certain level where it can't go beyond A and it's called the carrying capacity. So another example is a spread of a rumor. Spread of rumors and epidemics. Do you remember corona? Initially it spread very rapidly, right? But slowly it decreased and then it stabilized. So these are some examples of logistic curve. Rumors also it's like that. So there is one example. Let's do this. Do you all have any questions to ask from this? Okay, no questions. Then let's work out this one. Let's work out this problem. The number of soldiers at Fort MacArthur who contracted influenza after 3 days during a flu epidemic is approximated by the exponential model. So they always give you the exponential model and tell you, okay, according to this, or if there's exponential growth, you have to know that it is qt equals q naught e to the kt. Exponential decay, this. Or they say learning curve or this logistic curve. So spread of influenza follows a logistic curve model. If 40 soldiers contracted the flu by day 7, find how many soldiers contracted the flu by day 50. Can you try this out? So here again, you have to find K. Right? First step is find K. So in order to find K, they have given some data. That is, they have said by day 7, 40 soldiers have contracted the flu. So T equals 7, QT equals 40. So that is given. Q7 40 equals 5001 plus 1249 e to the minus kt. So if you cross multiply and bring the k down, solve for k and tell me the answer for k. What will be k? Find k. Did you all find K? What's K? Zero 0.329. Okay. So 0.329. Now what are they asking you to find next? How many soldiers contracted the flu by day 50? So once you know K, right? So what's K? You all said 0.329. So QT, day 50, 5,000 divided by 1 plus 1249 e to the power minus 0.329 into day 50. 50 multiplied by 50. You get the answer. So how many soldiers has contracted the flu by day 50? That's the answer. 508. 508 soldiers have contracted the flu by day 50. Did you all get 508? Okay, so that's the end of this chapter. I guess I have one more. Or did the course outline? Yeah, we did 1, 2, 3. I think I have one more chapter, trigonometry. Trigonometry. Okay, thank you for joining. I'll upload the recordings. I guess last time also I uploaded, but remember the recordings get deleted after 30 days or something. So if you want, you can download it and keep it for yourselves.
Recording stopped.